हेलो हेलो।
आज
स,
का टी ब्रेक साहब की तरफ से।
सभी को धन्यवाद।
कोई नहीं, पार्टी करने के बाद बिल सर आपके पास भेज दिया जाएगा। ठीक है, तो बड़ा खाना करा ले सर।
Hello, hello, hello. Hello, hello, hello. Testing, testing. Hello, hello. 1, 2, 3, 4. Hello, hello, hello. Testing.
Respected Sri Hemant Kumar Jha, Chief Instructor, SETCO BSF Bangalore, Sri TNS Reddy, Commandant Training, our today's distinguished guest, Sri Ganapati Pai, Director NetApp, officers, staff, and trainees. I am Vishal Rana, OC Training, and I welcome you all at this Tarang Auditorium to enrich our understanding about data management principles. First of all, I am thrilled to extend a warm welcome to Mr. Ganapati Pai, the Director of Product Management at NetApp, Karnataka University, who will be gracing us with his presence as our distinguished guest speaker today. Mr. Pai brings with him a wealth of experience, boasting over 25 years of progressive technology leadership in introducing groundbreaking products to market. His expertise spans across various domains, including real-time system SCADA, CRM, storage infrastructure, hybrid cloud, and many more. It's not just his professional accolades that impress, but also his ability to navigate cross-cultural global environments and lead cross-functional teams with fluency. In his tenure, Mr. Pai has not only excelled in product management and development roles, but has also been instrumental in mentoring teams to deliver products with impeccable quality and within tight deadlines. His journey is a testament to his dedication and passion for innovation in the ever evolving landscape of technology and data management. Beyond his professional achievement, one thing I just want to tell you, and it is also applicable to us since we are more or less concerned with our physical fitness also, apart from our intellectual knowledge. Mr. Pai sir has not only excelled in only product management, but Mr. Pai is also an accomplishment sportsman, representing Karnataka in table tennis at the national championship at the age of 40 plus category. Bracket. This speaks volumes about his commitment to excellence and his ability to balance both professional and personal pursuits with grace. Today, as Mr. Pai takes the stage to enlighten us on the intricacies of data management, let us embrace this opportunity to learn from his vast reservoir of knowledge and experience. I encourage each one of you to actively engage with Mr. Pai, ask questions, and glean insights. This will undoubtedly enrich our understanding about data management principle. So, without further ado, please join me in extending a warm welcome to Mr. Ganapati Pai. Please have a big round of applause for the sir. Thank you, sir. Thank you very much.
Good morning, everyone. So first of all, I would like to thank Reddy sir, Jha sir. Hello, can you hear me? So first of all, I would like to extend my thanks to Reddy sir, Jha sir, for providing me this opportunity to talk about data management. And it's an incredible pride for me to stand in front of you and talk about my experience. So today, as we talk about data management, the agenda that I plan to cover today is basically provide you an overview of what data management is. We'll start with what is data and what kind of data are we looking at today, and then look at what are the data management concepts that we have. So when any organizations having data, we need to look at what are the types of data that they have and what are the different concepts of data management are applied in that organization. Post that, we'll also look at some of the technology domains, and I'll share my experiences there as well. The first being SCADA. which is supervisory control and data acquisition. We'll go through the details of what these are, but I plan to cover SCADA as a domain. And then secondly, I would like to also talk about storage infrastructure. So when we talk about data management, this data has to be stored somewhere. And when you store this data, there are a lot of things that happen with respect to this data. That's where the storage infrastructure comes in. So we'll look at how this data is managed, how this data is protected, how this data is basically giving you a lot of insights so that you can take certain business decisions on it. So this is the agenda that I plan to cover today. And then I'll have some time for Q&A if you might have any questions around these topics. Okay? So with this, let me start off with an overview, right? So even before we talk about data management, what is data, right? So when I'm sure all of you are using internet, all of you are using mobiles, right? All of you are using, let's say, the products that Google has, Google Maps for navigations. What happens when you open up and use these applications? What happens when you use social media? What happens when you use different applications for videos, for streaming, for music, for social media platforms like Facebook, Instagram, all of those things? The main thing that happens is you generate the data. And there's a lot of data that happens every day, every hour, every minute. So this is all the data that we look at from a personal perspective. So when people start using this, they generate a lot of data. So for example, when you start interacting on Facebook, you generate data. If you start opening up Google Maps, you generate the data. Similarly, if you look at, so this is all about personal data, right? So now if you start using, if you look at industries, there's a lot of manufacturing industries as well. There's a lot of oil and gas. There's a lot of other industries, sectors. When you start using them, and when these, a lot of organizations are today connected to the internet. So when they start using these systems, there's a lot of industrial data that gets generated. Okay, so today if you look at data management, there's a lot of data that is getting generated, and it's very, very important for organizations to manage this data. So I'll give you some figures, right? So if you look at the overall internet access that people have got and the years that have passed through, if you look at the last 2 to 3 years, 90% of the data has been generated in the last 2 to 3 years. So much of data has been used by people. So much of data has been generated. In the next couple of years, this data is going to increase by 150%. So you can imagine the scale of data that we're dealing with every day, right? Also, if you look at the overall data that we generate, 50% of this data comes from video streaming. Most of you must be using YouTubes, right? So the way we stream this data, that is almost accounting for 50% of that. Similarly, any of your social media, platforms, Facebook, Instagram, or for music apps, Spotify, all of these are contributing significantly to this data. Any guesses about how many emails we might be sending in a minute? Any guesses? Emails that we send in 1 minute across the globe. The number is staggering. You have 250 million emails that are sent in a minute. So you can imagine how much of that data would be there in an hour, in a day, and in an year. Right? So why I'm stating these figures is just to give you a magnitude of data that is getting generated data every day, every single day. So for organizations which are maintaining this data, it is very important for us to manage this data. Not only manage this data, but have processes around this data to be able to govern that data. There are certain rules which we need to comply with when we manage this data. So those are the compliance requirements, regulatory requirements. So as this data gets exponentially increased over time, It's really important for us to see that how companies and organizations can manage this data. Not only manage this data, but also secure this data. So this data has to be secured because it's a specific organizational data. Not only securing this, but also using this data to be able to generate insights out of it. So this data can be worked on to provide you with a lot of insights. And these insights will help you take decisions based on this data. That is called the data insights. Right? So now coming back to what data management is. So data management is a practice of collecting this data, monitoring this data, and managing this data. Right? So when you have this data, it's also important for us to govern this data. So what does this mean? So you have a lot of processes in place. So one is the data creation itself. There are various channels through which this data comes in. It's not only one channel, there are multiple channels through which this data comes in. How do you access this data? How do you integrate this data? And how do you bring across this data from various data sources across one single place? That's the governance part. You're also looking at how are you storing this data. So there could be some data where it is stored at certain branch locations. But then you also want to consolidate this data across your master location as well. So you have a lot of locations where this data gets generated, but you also want to send it across to your master location. So when you have this data, it is very, very important because a lot of people are using this data in your organization. It is important that you secure this data. It is important that you provide the data all 24 hours. So the data has to be highly available. It can't happen that certain business critical data goes down and you're not able to access that data. So it's very important for us to provide this data, protect this data, make it highly available at all places, and then have a disaster recovery in place. For example, if there's data at one place which goes down, you need to be able to automatically shift it to the other location so that the data is always available for you and restore your applications. Then you have data integration, which means, as I said, there are different locations from which this data gets generated. You also need to integrate this data, bring it across one single place. And the last one is data privacy. So there's a lot of data that is there with the organizations. It's not that everybody has access to all the data. It also depends on which people have access to which data. So that is the data privacy that we're talking about, and data security. So with this, I will just introduce some of the concepts. Again, this is not a holistic list. I just want to give you a high-level gist of what are the most important things that are important when you talk about data management. So the first one is data architecture. So as you know, there's data coming in from various sources, right? So this data could be, normal data, it could be structured data, it could be unstructured data. There's a lot of formats in which this data comes in. So it's very important for us to have a data architecture in place. There has to be a structure in which you can get this data into your locations. That is the thing that we talk about when we talk about data architecture. There has to be a certain structure that needs to be defined for your data assets. Okay. Then we talk about data security. So data flows, data comes in, you have to encrypt this data. How do you provide security for your data in terms of giving access to only the people that are required to read this data? Not everybody has access to all the data. So you need to have data security in place where you can give these policies for certain people to have access to this data. Then you have data integration, which involves moving that data across various sources, consolidating it into one single location. There's data coming in from different places, you need to consolidate into one location. Then the governance part of it comes into place. So there are certain regulatory requirements. For example, if you have certain data, which is basically a personal information, you have certain rules in which you need to retain that data. You have certain rules in which you can't expose this data. The way you retain this data is also important. So these are all the compliance rules we need to be adhering to. So you need to be able to understand where you have some data as to what kind of a data it is. Is it like a very critical data? Is it like a hot data, cold data? Is it accessed every time, every day? Or how do you want to generalize this data? What is the critical information that is there within this data? So that is all part of the data governance. How much of retention would you have on that data? Those are all part of your governance and regulations. Last but not the least, the master data management. This is where you would want to maintain your data accurate, up to date. So this is the master data. Like you might have core entities like employees, product, catalog, similar other entities you might have within your organizations. How do you retain this as a master data and then keep it up to date information is your master data management. So these are some of the concepts that we have within our data management, and it is very important that we have this in place when you are dealing with a lot of data. Okay. Now with this concepts data management, I will go a little further and talk about one of my experiences that I had while working on a domain called as SCADA, which is supervisory control and data acquisition. So we'll go through that. So what I'm going to cover today is look at what is SCADA, what does supervisory control and data acquisition mean, what is the problem statement that we have and what are we trying to solve there. So why people would need SCADA, why somebody would, an organization implement a SCADA system, what is the importance, what is the benefits you get out of that implementation of SCADA systems. And then we look at what is a typical architecture that a SCADA system would have. What are the different systems in place? How do we gather the data and how do we process that data? We'll look at that. So this is what I'm going to cover as part of the SCADA domain. Now what is SCADA? So SCADA are basically systems that are used for controlling, monitoring the data and analyzing your industrial devices and processes. So it could be applied to any sector, essentially where you want to monitor your devices or processes and analyze the data to be able to take decisions on it. So this system involves both hardware and software. We look at those, what are these hardware components and what are the software components in this particular systems as well. But SCADA systems will have software as well as hardware components. It can be used across various domains. It could be manufacturing, it could be oil and gas, it could be power systems, it could be water management. You name it, name the sector, you can have SCADA system there. As long as your need is to monitor the data, control the data and analyze the data for future actions, you can use SCADA systems. Okay. How does it help? Is once you start monitoring this system from a central location, you can optimize your production. You can optimize the processes that happens and then align to that particular regulatory systems, regulatory requirements that your organization might have. So typically what happens is if there is a system where you need to monitor in the field, there are certain equipments in the field which you need to monitor. Now it becomes very difficult if they are geographically distributed, you'll have to manually do it. How SCADA system helps is it brings all of this together into one single place. So troubleshooting issues in the field is a problem today when there is a manual intervention that is required. This is what SCADA solves. As I said, it is centralized monitoring, which means these equipments or these devices that could be in there in geographically distributed locations, it could be any distance. You will be able to centralize this at one single place and you can monitor these devices. Not only monitor these devices, but also control these devices and analyze the data that is coming out from these devices in the field. As you control, you can automate certain things. When you have certain conditions met, you can act on it. So you can set up certain automations when you want to scale up. You don't need manual intervention, you can automate it. This is why people would use SCADA systems. And there's cost savings as well because there's a lot of manual effort that gets reduced and you can automate a lot of things. So that's why we have the cost savings there. Now, what is the problem statement, right? So we looked at why people would use SCADA systems. It is basically the lack of the overall system health that is not visible today. You have devices, equipments in the field which are geographically distributed, but you don't have visibility of your overall system health. That's one of the problems that we have today. There's significant manual overheads when somebody wants to monitor these devices in the field. So let's say you have like 5 locations where your devices are there. You have to manually go and check these devices to be able to look at what the devices are functioning. The next thing is there's no alerting mechanism. If these devices have certain problems, how do I alert? How do I know this beforehand so that I can remediate that alert? I can remediate that issue. I can fix that issue even before that happens. So these are some of the problems that we have, and operational delays due to manual overhead. So when somebody is doing it manually, there is an operational delay that happens because of that. Also, you don't have, like when you have certain devices, you will also want to report this, like how this device has been performing for the last 6 months, for the last 1 year, to be able to know how your systems are behaving. So this reporting, lack of reporting is also a problem today. So these are all the problem statements that we have today, because of which the SCADA systems are going to help you achieve or solve this. So let's look at a generic architecture of how the SCADA system looks like. If you look at the bottommost layer here, sure, thank you. If you look at the bottommost layer here, this is the field, right? So these are the field devices. If you look at this, these are sensors which are attached to your field equipments. These are the sensors that are going to send you the data back into the systems. Now there is something called as a RTU here and the PLC. So these are connected to these sensors. The sensor sends this data back to the RTU. RTU is basically a remote terminal unit which collects this data from the field. So any data that you have in any of your sectors, these devices or sensors can send you data back to the remote terminal units. This is where the raw data comes in from the field. Now these RTUs are responsible for sending this data back to something called as a host. So this is the supervisory control. This is the central system where it will have all data coming in from all RTUs across geographically distributed devices. Okay, so this is the SCADA server or the system which is going to hold all your data. Now once you have this particular data, you can have connections to any of your client systems, which is a desktop. So any person sitting in a central location can have information about your field which are geographically distributed. And then this person sitting here on this terminal should be able to monitor your data and control your data. So one example that we had was NTPC, which is an organization which has several branches today in India. Each location collects certain data of power systems into their local locations. And then this data gets transmitted to the head office in Delhi. This is how they monitor their all locations sitting at one location. The other example is one of the railways project that we did was a section, the railway section that we had in UP, and this had like 7 to 8 stations where there were electrical substations in place. So every time the railway has to come in, you have to, based on the station that it's coming to, operate the circuit breakers so that the power to the line gets activated or not. Now this used to be a manual effort. So now what we did with this SCADA systems is all this information is available at one single place where the operator who is sitting on that particular terminal has access to all the substations data, which is like 7 to 8 substations, And then based on the trains that are coming out to each of these stations, they can control it. So let's say the train is coming to one station and there's another train coming from the other station, and there's only one line. They cannot come at the same time. So somebody will have to stop the train before the station comes in. And that's where you could operate on the circuit breaker so that the power to that particular line goes off and the train can stop there. So this is how you can essentially control sitting at one location for the entire stretch. So this is how the SCADA systems help consolidate the data, that is to monitor the data, and to also provide control where you can operate the field devices. So this is about the SCADA systems. Now I will move on to the storage infrastructure. So the SCADA systems was one application of how you would use the data to collect the data, monitor the data, and control the outcome of certain equipments. Now the second experience or the example that I'm going to talk about is storage infrastructure. Now you all would have been working with different applications that you are using, be it email, be it any of your booking apps, be it any of your other specific internal apps that you are using. Each of this has data. Now this data goes and sits into a database. Now what happens below that, what happens below the database is basically what we are talking about here in terms of storage infrastructure. Where does this data go and sit? What do we do to enable this storage infrastructure so that the data can be coming and stored in that particular storage boxes? So we look at what is that, what do we mean by storage infrastructure? Then we also look at a high level architecture of what the storage infrastructure looks like, and then different use cases of how do we set up the storage infrastructure. So storage infrastructure basically refers to the overall set of hardware and software components needed to facilitate storage for a system. So as I said, you have a lot of data generated from your applications. How does this data go and sit into a storage system? Right? So the storage infrastructure basically talks about the hardware and software components that are responsible for this. We also look at how do you manage your overall storage infrastructure so that you can have a continuity of business. As I said, your business applications are really critical, which means the storage cannot go down. You always need to have that data in place to be able to manage your applications or work with your applications. So we look at how do you manage your storage infrastructure there so that we can have a business continuity and it's never down. It's always available for you. So it's also important what is your management process and what are the different tools and service levels that are required to maintain this. Also, when you have a storage system in place, you have different levels of monitoring that you do. Your storage has capacity. So you also have to manage that capacity. You have to look at, okay, when is my storage going to be full? Should I plan for my extension of capacity? You have to look at performance of your storage system. How is my storage system performing? How can I improve the performance of the storage system? Then you also look at, okay, how do I secure my systems? How do I protect my data? What are the mechanisms in place to protect my data? So we'll look at all of these concepts as well. Not only that, when you have a storage system in place, it's also important to monitor that data. Why do you monitor? You basically monitor that what is your system health? What are the things that I can do to improve my system health? How do I alert my systems? So all of those things. So this is the overall storage infrastructure that we're talking about. So if you look at the client box there, if you look at this client system here, so we all work at this level. So you have either a browser, laptop, or a desktop where you have applications running here. So when you save certain things and when you create certain things, this data goes into a server. So there is a server here which hosts this particular applications, and this server is responsible for sending this data over the network to the storage boxes. So these are the storage boxes where your data is stored. Okay, so this is where your data gets stored. Now there is this server here, and then you also have another server here storage here. This is basically the HA pair that you have. That is the highly available storage arrays that are available with you. So you have multiple controllers which are highly available, that even if one goes down, you have the other one which is available. Similarly, if you also have look at the server side here, there's also servers which are available which will take care of the HA part. Okay. Now to do this setup, so every time an organization needs to have a storage infrastructure, they would need to set up this storage infrastructure. When we say setup, what does that mean? So let's say you've bought storage boxes. How do you set that up? What do you do to set up these boxes? So of course you'll have to do the physical wiring of these boxes to the host, but apart from that, how do you set up your storage boxes? The first is called the day zero setup, which means whatever the physical connections you've done, you basically manage it via the software. You configure your network, you configure your systems, you configure your protection. So once that is done, you would want to create storage volumes, capacity, where this data goes and stores into the storage boxes. This is called the capacity planning or the capacity management. How do I ensure that there is a volume that is created where data goes and sits into it? And then this volume is not only used for storing, but this also has to be protected. So for example, if my storage boxes is in Bangalore, I have my data stored in those boxes, but then this is not the single point of failure. So if there is a box that data gets corrupted, what is the backup or what is the backup mechanism that I can have? So for this, I need to also protect this data across the other geographical location. In case of data corruption, in case of disaster recovery, how do I recover from it? So that is the reason, apart from Bangalore, I would also have another geographical location where I would store this data. Okay, that is called the DR setup or the disaster recovery setup, where apart from Bangalore, I would also have another location where I would store this data. So that whenever you store data in this Bangalore location, this data gets replicated to the other geographical location as well. Yes. So for example, if there is some issue at Bangalore location, you should be able to quickly restore your applications from the other location. So that is the DR setup. Then you have the performance management. If there is any issues with your applications which are running slow, or certain issues with your applications which are not accessible, then you need to look at the performance aspects of it as well. So probably there is some issue with the hardware, probably there is some issue with the network. So with this, you should be able to manage where this issue is, troubleshoot where the issue is. So the system software that are available for you will identify whether it is like an old hardware that is running because of which you have performance issues, or there is some issue with the network that is causing this performance issue. So you should be able to detect that and then do your troubleshooting and fix those. So performance management plays a key role there when you have applications running on top of storage infrastructure. Then you have the security management. Now, as I said, you have data. It is not that everybody would have access to this data. There will be certain administrators, there will be certain roles which you will define for each person, so that this person or this role has access to only specific data that is available. Right? So for example, if there's a financial data, only the finance team should be able to access that data. If there's a marketing data, only the marketing people should be able to see this data. So depending on your departments or depending on your roles, you should be able to access permissions to that particular data, or what you can do with that data. Yes. And then you have compliance reporting. So when you have data, it's also important to understand what kind of data it is, whether it's a personal information, whether it's a critical data, whether it's important data, what kind of data are you storing. It's very, very important to understand this and then classify this data based on what kind of data it is. That's where the compliance reporting also comes into play, where we would like to understand and then report these are the kind of data that we have within our systems. Last but not the least, monitoring is where you would monitor your data. The capacity data for capacity planning, which means if your capacity is filling up, we will be able to tell you, okay, in the next 3 months your capacity is going to be full. You need to plan for extension of those capacity systems. You need to have capacity planning in place. Then you also have certain issues that might come up with respect to securities. If there is a security vulnerability in your system, we'll be able to alert saying that, okay, there is some security problem with your system, you need to remediate it. So those are all the alerts that you would basically monitor so that you can fix it before even they occur. So these are some of the systems, some of the things that you would do to set up your storage infrastructure systems. So with this, I would like to complete my talk about data management. So what we looked at is initially looked at what is data, what kind of data are we looking at, be it personal or be it industrial data. And then we also looked at the data management concepts. What is important for an organization which is managing large amounts of data? What should we be taking care of in terms of architecture, in terms of processes, in terms of master data management, all of those things. And then we looked at two areas. One is the SCADA domain, where you are basically getting the data from the field, from the equipments, to be able to monitor those equipments and then be able to control those equipments based on the data. That's the SCADA domain. And then we also looked at storage infrastructure, where once you write the data, how does it go and store into the storage systems? And what are the things that we need to do in order to set up the storage systems in place? So this was a high level talk about how do we manage the data in various domains. So with this, I would like to end my talk and be able to take any questions that you might have. Thank you so much. So you can have wired or wireless protocols that are, yes, both are possible. Sure, sir.
My question is for the SCADA. For the SCADA domain, does it the vulnerabilities are involved in it, and how can we use it in BSF while controlling our equipments with this the SCADA application or the PLC?
So yeah, so security plays an important role wherever there is data. So whenever we talk about data, security is very, very important. It's critical. So there will definitely be encryption of the data when you pass along when you talk about the SCADA systems. So you'll have devices in the field, you'll have sensors in the field, and these sensors are passing the data back to the SCADA systems. So this data that gets passed will be encrypted. There are certain security things in place over the network that gets encrypted and that are secured. So that data is definitely secured there. Not everybody has access to that data. You definitely have authentication mechanism to be able to access those data as well.
Problem of acquisition of data from the sensors, because probably there was some I mean they don't want to share that this thing how I mean this last time when the CIBM's project was there in our border, so that was one problem where all sensors data we could not fetch from that point of acquisition.
I think when you talk about these sensors and hardware devices, I think climate and nature plays a lot of role there. So probably because of certain natural conditions, like it could be wind, it could be rains, it could be dust, probably they could have affected the performance there, sir.
Keltron, one company is, I think probably they were given this task to do that, but somehow they failed to do that.
Okay.
One sore point whereby
Sure.
we couldn't get the data from field. Anyone can ask any questions because you should not feel shy about that because it is not that you don't know and you don't ask the questions. If you don't ask the question, you'll never know the things.
So like we have lots of data stored in our servers, in the basic servers, and if that data is breached, then how can we protect them from the attackers?
So I think that's where the security mechanisms comes into play. There's a lot of security solutions that are available today which can detect the breach of this data. Of course, breach is something that it's very difficult to detect beforehand. When this happens or before this happens, you basically know what are the things that are changing with this particular data. So there are different mechanisms by which you can basically detect that there is a breach of this particular data. So there are various mechanisms in terms of so there's some data. There is a track of where this data is getting modified, who is accessing this particular data, what time is this particular data being accessed. So there are various mechanisms by which we can identify this data has certain breaches or not.
So like in the movie named Genius, we have seen that he sent some virus to the receivers who is getting the data, and that virus is obliterating all the data he has received. So how can do that? And
so I think any external thing that you work with, you'll have to be really careful there. Instead of any viruses that you have will probably have some file to be installed on the system. So you have to be really careful about what files you install on the systems as well.
And so is it possible to send some virus and that we have to destroy all the data the user has received?
It is possible. That's why I'm saying that you have to be careful in terms of what external files you work with and getting installed on the system itself. You'll have to be very careful with that.
Thank you, sir.
I think all IoT devices are vulnerable. So you need to have that kind of security in place before you acquire the data from the field.
Right. Yes. So you have different algorithms which you can use on the data sets. So once you collect the data, there are various AI ML algorithms in place to be able to predict. So you can also see the pattern of your data, how this data is changing with respect to time. And then based on the data set over a period of 3 months to 6 months or whatever that is, you should be able to predict the future mechanisms. There are algorithms in place.
Thank you, sir. Thank you very much for such a splendid and wonderful session. Now I would like to request DIG sir and CO sir to just come on the dais and give a memento as a token of remembrance.
Thank you so much. Thank you so much, sir. Thank you so much, sir. Thank you so much.
Now I would like to request DIG sir to say a few words about this session, sir.
ये देना मेरा मोबाइल देना. Shri Ganapati Pai, Shri TNS Reddy, Command and Training, officers, SOs, and my dear friends. I hope this session was very interactive and being helpful for you in understanding the data management. As you know, this data is very important. Whatever you do in this field, I mean, whether you are in the field, you are using the mobile or using this YouTube or accessing the web, every time you do something, there is some data, some event is taking place, and that data is being acquired by, and you are giving this data to this multinational companies, the web browsers where you are accessing these sites and all. So data is being acquired from them. Nothing is free in this world. The data is the new oil in the modern world. So then when we are getting all this data, it is very important that the data should be managed also. Similarly, the companies who are acquiring the data on the same pattern, you know that we have a very ambitious project like CIBMS, BoldKit. I think you might have heard about that. Okay. So this kind of projects are being implemented on border. So this data is also important for us, and probably in future, because it is in segments now, but probably in future, it require this kind of system on our borders also. And our borders are very unique. The terrain, you know, there is somewhere there is desert, somewhere there is a hilly feature, then there is undulating grounds, and we have different kinds of sensors which is likely to be placed on border. Now these days we have lots of CCTV cameras placed on the border. LCTS solutions are there. Maybe in future there will be more sensors and all this anti-drone systems. Then many other things will be placed on the border, and it is therefore very important that these kind of data are acquired from the border, and then this, after acquiring this border, for this data from the border, it is important that we utilize that data for some purpose, for decision making. So those data has to be acquired, then transported to a central location whereby we can analyze the data and then take our decisions. Like if something is happening, whether there is probability of that thing happening in future, and what actions should we take based on the data we acquire. So this kind of things will be implemented in future. As you know, this SCADA system, as Mr. Pai was saying, that the SCADA system is being used in industry, like oil and gas, this grid system, and all these places, these things are being used. And this is world over, this system is used successfully. So this system has been tried and tested. So this system could be also implemented on borders also, whereby we can get this data and we can use it for predictive intelligence and then for prescriptive things, like what action should take in future. So we can plan those things. So this session was very useful and enriching. I am thankful for this session, and hope that in future also we'll have this kind of sessions. Thank you so much. Thank you. Jai Hind.
Now I would like to invite Head Constable RO trainee Aditya Pancholi for a vote of thanks, sir.
A warm good morning to one and everyone gathered here. It's my privilege to propose a vote of thanks and acknowledge the contribution of those who worked really hard to make this event possible. I, Head Constable Radio Operator Aditya Pancholi, on behalf of Shri Hemant Kumar Jha, Deputy Inspector General, Shri T.N.S. Reddy, Commandant, all officers, subordinate officers, and my trainees, extend my sincere thanks to the Almighty for making today's event even a grand success. I extend a hearty vote of thanks to our guest speaker, Mr. Ganapati Pai, who spared time from his busy schedule to grace the occasion. Today we had an opportunity to hear your valuable knowledge, and this will surely encourage us in all our future endeavors. Your thoughts have enlightened our minds and have shown us a new path. You gave deep insight into the topics and revealed some interesting facts. I also want to extend thanks to DIG sir, Commandant sir, all officers and subordinate officers and trainees as event like this cannot happen overnight. These wheels started rolling weeks ago. It requires planning and a bird's eye for detail. We have been fortunate enough to be backed by a team of very practiced and dedicated staff. Thank you so much.
Everyone, I would like to request everyone to just stand up for national song.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Turning us to take charge.